Hello, AP Statistics. This is day 2 of your 2020-2021 school year, and we're going to talk about section 1.2, which is displaying quantitative data. Here we go. So here's what I got. I'm going to talk about McDonald's French fries again, because again, they are amazing. For many of you, you're seeing this on a Friday, and if you have the McDonald's app, a medium fry is free as long as you spend $1. So go get your $1 drink, get a free fry, or go buy a bunch of cookies, get a free fry. In the end, though, here's what I did. I have 16 unique occasions where a medium French fry was purchased at McDonald's and the fries were counted, okay? And these 16 that you see over here, where are you at? There you go, are the counts, okay? Who counts their French fries? Maybe only a nerdy math teacher, okay? But here's what they like to do. They would ask you to make a dot plot. And you're like, what is a dot plot? Let me tell you, it's so easy. Okay, so here's what I'm gonna do. I'm gonna draw a graph. Ooh, that's way over there. Okay, and then I'm gonna go the other way. Oh, that got big fast. Don't know what I did. Okay, and I'm just gonna do some counts, okay? Now, it looks like the smallest one I have is maybe 45. And the largest, if you look at it, maybe 55. All right, so let me do that. I've got 45. I'm gonna count by fives, 46, 47, 48, 49, 50. And I say count by fives, I'm just gonna write the counts this way by fives, but everything in between is recognized. So that's 46, 47, 48, 49, 50. Okay, so, and then I got 51, 52, 53, 54, 55. If I am going too fast, you can always pause this, all right? And I want to label this. AP really wants you to label your graphs, okay? So I'm going to write what I'm talking about here. These are the number of French fries in a box. Number of fries in a box. Cool. Pretty easy. Now vertically, I'm going to write frequency. And it's hard to write vertically, I'm just going to tell you. Because you can't really turn your slates that you're drawing with like a piece of paper. Nevertheless, I pulled that off. Thank you. All right, and then here's what I'm going to do. I'm making a dot plot, which means I am making dots where I see these numbers like 45. So here's 45. Let me just put a dot there. And the next one is 48. That goes here. And 47. You see here. And then I got another 47, so I'm going to put the second one above it. And then 50, 51, 46, 46 again, 48, 47, 47 again, 49, we'll sneak that in there, 46, 48, 55, and 49. There we go. All right, so here's what I'm going to do. That's not hard, okay? I know you can put numbers in those places. Where do people get problems like this wrong? Well, they don't label it, okay? Or they don't write labels on the side, either horizontally or vertically, okay? Or maybe they don't write numbers here cleanly, okay? So it's more of the technicalities that people will mess up on. Further, I'm going to count these dots. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, let me count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, got enough. All right, so that looks good. That would earn perfect points on an AP exam. And then they ask you to describe the distribution. Okay, now I put in parentheses here, shape, center, spread, outliers, because that is what they want you to do, okay, when they ask you to describe the distribution. However, keep in mind that they won't always put those in parentheses. They'll want you to do this part that you see in bold, and you'll have to know that they want these 4 things. Okay, now, I probably should have put these in order, like this, because socks is easy to remember, even though it's not written this way. Nevertheless, we can still pull this off. Shape. Okay, now, if I look at my shape here, it does look somewhat mound-shaped. And I wouldn't say that it looks too unbalanced, okay, other than this point that's kind of hiding out to the outside. And so I'm going to say that the shape of the distribution of French fry counts is approximately normal. And you're like, what is approximately normal? Well, that is what mound shape is in fancy statistical terms, okay? And we'll talk more about that in a second. So I will say the distribution of French fries in a box is approximately normal. Okay, now, not only did I talk about distribution, but I want to emphasize one other point here. And that other point is, if I can find it, this piece here. It says the distribution of French fries in a box, okay? I am writing that in context, okay? So what that means is, I'm gonna make that a little better, is that I'm talking about the story within this problem, okay? And you need to do that when you answer most questions in the statistics class, all right? They want you to put context in your answer. Okay, I'm gonna try this again. French fries in a box. A little bit better, okay? So you don't have to do it in all 4 parts. Just make sure you do it in at least one of those 4, okay? If you don't do that, you can lose up to 1/3 of your points on an AP test. Does that sound steep? It is steep, okay? So just make sure you do it. All right, outliers. Does it look like there's an outlier? Remember, an outlier is a data point that looks like it's further away from all the other data pieces. And if I had to take a guess, it looks like maybe 55 is an outlier. Okay, so 55 is a potential outlier. Some people would say, how do we know if it really is or if it's not? What is the cutoff to say that something is an outlier or not? Hang on to that great question, okay? Because later on, we will have a fancy calculation that will determine that, okay? But for now, we're just gonna eyeball it and make a determination. Okay. All right, C, again, that stands for center. Okay, so I'm just gonna write that in so we don't forget, okay? And center, again, is the median. Okay, it is not the mean, it is not the average, okay? So it is the middle number. And so if I count my 16, what that means is I would have to, well, cut that in half, that's 8. And it means I gotta go 8 in each direction. So 1, 2, 3, 4, 5, 6, 7, 8. There's 1. And if I go the reverse way, 1, 2, 3, 4, 5, 6, 7, 8. So I've got 2 in the middle for my median, okay, for my center. And so you can see that one of them is at 47, the other one is at 48. And I really don't want to write 2 centers. And if I have to, what that means is you will have to average them, okay? And that always happens when you have an even number. You can see that that 16 there is an even number, and that means you're going to get 2 of them. And so if we average them, add them up, divided by 2, your center is 47 and a half. Okay. Notice I didn't put these in context. These O and the C, you didn't have to. You only have to do it one time, okay, which we already started off with. Okay, last item is the spread. And for the spread, I've already acknowledged there's an outlier, so I'll just say the spread is 45 to 55, okay? And again, it's with an outlier. All right, any questions on that? This, of course, is a lot of script. And you're like, man, for a math class, that's a lot to write out, okay? But again, this is a question where you're describing things on paper that you're thinking about in your head. And you have to include all the components of a distribution, which is right here, in order to get full points for your answer, okay? In order for it to be complete. All right, pause that, think about it, okay? And if you have any questions, think about it. You can ask those later, okay? And again, you have to have all four parts with this context, okay? If you forget one piece, chances are you're going to lose a third of your points. If you forget two, sometimes you lose, 2/3 to a half, okay? And of course, if you miss a little bit more than that, then you may not get any, all right? So make sure that looks complete. All right, now we know what approximately normal looks like. I kind of gave you a picture that looks like this. It doesn't have to be perfect. And the reason why it doesn't have to be perfect is it says approximately, okay? Rarely does our data become perfectly normal, okay? It'd have to be pretty lucky and pure to have that happen, okay? All right, skewed towards higher values means that your normal curve is gonna look a little lopsided, okay? And what that means is if I say towards higher values, that means your tail is gonna be on the right side. Okay, so it's always skewed to wherever the tail is. Conversely, if your data is skewed the other way, okay, towards lower values, that means the tail is on the bottom side, okay, or the lower side. Which way is the better way to say it? It's accepted either way. I tend to use the word lower versus higher instead of right versus left, because sometimes you'll have skewedness that will be looked upon in a vertical sense, okay? And I always like to read numbers in terms of whether they're lower numbers or higher numbers, okay? So it's up to you. Uniform. Imagine if you roll a dice, say 600 times, okay? And you recorded all the outcomes on your dice, okay? What would our outcomes look like? Well, geez, I don't know how many I'd have of each, but since dice are typically fair, my guess is that I would have about 100 of each, assuming that you rolled your dice 600 times. Maybe 100, somewhere right there. Now, will it always be exactly 100 for each one? No. Okay. Sometimes you'll have it be have instances where some sides will appear more often. Okay, like maybe this 5 here. Sometimes it may be a little bit short, like this 3 maybe look a little short. Okay, but in the end, it should be somewhat level. Okay, and if your data turns out to be somewhat level, and not perfectly level, but somewhat level, we say it's uniform. All right, last one of this type is bimodal. Okay, and again, bi meaning two. Okay, suggests that, and mode meaning most common, means that you're going to have two moments in your graph, okay, where you're going to have some peaks. Okay, maybe you have one right here, and you have another one right here. Imagine if I had shared the bench presses, okay, that athletes have between the cross-country team and the football team. Okay, cross-country runners are tremendous athletes, but maybe they don't have the upper body strength that a football player has. So maybe your cross-country group is somewhere over here, and your football player is somewhere over here, and there is a huge gap between their weightlifting benches, okay, between the two different types of group within your the group you're studying. Okay, so always address that there is a gap in the middle. Okay, that was once important for an AP exam. that not only did we recognize two unique peaks, but that there was a set of emptiness in the middle. And sometimes it'll extend all the way to the bottom where there's really none. Okay, it just kind of depends on your distribution. Okay, all right, don't forget the gap. Moving forward, says this, okay? Presented below are test scores for last year's AP exams gaming, okay? They would like you to make a stem and leaf diagram or a stem plot, they mean this is the same thing, okay, for the respective exams, okay? Then describe the distribution. Okay, now, I bet you've done this, but you probably did it maybe 4 years ago in your Algebra 1 class, okay? Here's what I'm gonna do. I'm gonna draw a straight line. Oh, darn it. Okay. And I'm going to put an S here for stem and an L here for leaf. And I'm going to put some numbers on each side here. All right. Now, here's how I do that. In this particular case, I'm going to look at my 2-digit numbers and I'm going to represent my tens column for these numbers in my S, and the leaf will represent the ones digits. Okay. So if I look at, okay, all these scores here, it looks like the lowest is 40. Okay, so what I'm going to do is I'm going to put a 4 here. And the highest that I see is 100. So 100 really means that you have 10 tens. Okay, so that will go on the bottom. And I want to include all the numbers that are in between that. Okay. And then off to the right, I'm going to write the ones digits. So in this particular case, 95 means that I'm going to go down to the 90s and then put a 5 to the right. The 100 means that it's a 100. Okay. So the 10 goes here, the 0 goes there. 92, 84, and then I'm just going to continue through all of my data. 96, 74, 96 again, 85, 99, 93, 78, 82, 71, 40, 88, 93, 89, 68, and 85. Okay, I'm going to count my L's, so the circle, the numbers that are within the L column. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and there are 20 numbers up here. So I didn't forget any. That looks good. You'll notice that I don't have any numbers in the 5 area over here. So does it make sense to put a 0 here? No, it does not make sense to do that. That would suggest what? Yes, that I had somewhere in this data a value of 50, which I do not. And what that means is I have to erase that, and I'll do that right there. Okay. So if a column is empty, okay, so 2 things. Don't put a 0 there. And then further, okay, don't eliminate the 5 and then put the 4 like right next to the 6. Okay, make sure you create an equal interval between each of these values here, these tens values, and don't make one of them different. Okay, don't leave one out. Okay. All right, so this looks pretty good, but there's something a little uncomfortable about it. Okay, and the part that's uncomfortable is, well, everything looks pretty clean. The part here to the right should always be in numerical order, okay, in ascending order from lowest to highest. So in the English class, sometimes you have a rough draft. This here is your rough draft. And you're like, oh my gosh, do I have to do another one? You do, but you know what? These aren't hard. These are pretty easy. So watch what I'm gonna do. Oh, let me try again. Okay, so stem, leaf. I'm going to make it look just like the other one to start with. 40, 50, 60, 70, 80, 90, 100. Okay, 100 is 10 tens. And I'm just going to rewrite the ones in the leaf, but put them in order as you start moving from left to right. So here I have 4, 8, 1. I'm going to write those in order 1, 4, 8. Okay. Similarly, I have, gosh, 7 items here. I got to put these in order. So 2, 4, and it looks like I have 3 5s, and then an 8 and a 9. Okay. And then underneath that, I've got 2, 5, crud, forgot the 3s, didn't I? So let me erase that. This is why I make students work in pencil and not pen, because you make mistakes. 3, 3, 5, 6, 6, 9, and 0. Okay, so that is a pretty darn good looking stem plot. Okay, and there's only one more thing I'm going to put, and that is a key, so that people know what I'm talking about in context. And I'm just going to pick one of these numbers. Okay, I'm going to pick 74. And 74 is represented by 7 bar 4. Okay, so when I see something like this, I know what it means. Okay. All right, last thing, describe the distribution. Here's what I would typically do. I would tell you in class, try this on your own and see if you can describe it the way we've been doing, okay, including all the 4 pieces that we need, all right? Maybe hit pause and try it on your own, okay? And then when you're done, you can look at my answer, all right? So take a minute and pause it and see if you can do it. All right, did you pause it? I hope you did. Here's what we got. S, let me pick a different color because I'm sick of red. Blue. Okay, so S stands for shape, okay? And if I look at this, I would say that it looks maybe a little bit skewed. Maybe not. If I look at this, these are pretty balanced, okay? We have a little bit of items here. It may be a little bit skewed towards lower values, but not a whole lot, okay? So if I were to make a judgment here, okay, I would say test scores, okay, there's my context, sorry, okay, are approximately normal. There's not a whole lot of data to it. Okay, which is why it doesn't take too crazy of a shape. And again, I've already introduced the context, okay. O stands for outliers, and is there an outlier? Yeah, maybe 40. Again, we haven't found a rule yet that will decide what a cutoff is for an outlier versus not, so I'm just saying potential for now. C is the center, and I again have an even amount of items. I have 20 data pieces, okay? So I'll have to count 10 in each direction, and I got 10 by just cutting that in half. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I went the other way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's between 82 and 88. So 85 and 88. So cut that in half and you get 86 and a half, okay? And I'm just gonna say that is my center. All right, finally is S, and that is my spread. And the lowest number is 40, the highest is the 100. So I will say the spread, okay, is from 40 to 100, and just knowing that 40 again is an outlier. There you go. Okay, so hopefully you had something that looked pretty close to that. Again, don't forget the context. Okay, you have to put that in somewhere. I just put it at the beginning so I don't have to worry about it at the end. But that looks pretty complete. One of these days we're going to do one of these where we have an odd number and we don't have to add them up and divide by 2. I cannot wait. Excellent. All right, so listed below are the number of points the Arizona Cardinals scored in 9 games during the 2015 season. Okay, it says create a split stem and leaf diagram using the data. Okay, now we haven't done a split stem and leaf, but we have done a stem and leaf. And sometimes they're like, what's wrong with just doing a stem and leaf? And if you look at the numbers, something's unique about them. Imagine for a second if I were to do a stem and leaf. Well, if I did it like the last way, my lowest number is 31. So I have the 30 here. And the highest number is in the 40s. And if I try to put numbers behind here, all I'm going to get is 2 rows of information. And is it easy to create a description or a name for a shape when you only have 2 rows? And the answer is it is hard. Okay, you can't describe the shape of a set of data when you only have 2 rows of information. So if you don't have a lot of values here, okay, then what you do is we do something called a split stem and leaf. And this is just a small example of that. I'm going to try to find ways to make more columns, okay, or more rows within my stem and leaf. So I'm still going to use 3 because I don't really have another choice. And I'm also going to use 4, but I'm going to do 2 sets of each of those numbers. Okay, so a 3 here and a 4 here. And what I'm going to do is make my first 3 values 0 through 4. And the second 3 is 5 through 9. Okay, and then the same thing on the bottom. Again, this is my stem, this is my leaf. And I'm going to put them in. And I'm going to start with the lowest number just because I don't want to make a rough draft and a new one. It's easier to do a final draft when you only have 9 numbers like this. So let's see, 31 is my lowest number, I think. And then I have 2 34s. And those would still fit in this column here, okay? Or sorry, this part of the 3 from 0 to 4. So I got 4 here and another 4. And my next lowest 30 is 38, so that would go here. And then 39. And then it looks like my next one is 40. And then 42. And then 47. And then 48. 47. Okay, so that is basically it. That's just what we call a split stem and leaf. Again, it gives us a little bit more balance in our data. It doesn't feel so congested in one piece. If I were to describe this data with just the shape, it looks somewhat uniform. It's just I have one extra piece right here, but everything else looks pretty balanced. And in terms of the representation, there's 2 for each of the for the rows, except for this first guy. So, and there's really not much more to say. It doesn't say describe the distribution, so I do not have to do the SOX acronym answer. How do you like that? The one time they give us odd values and they don't ask for the center. Who wrote this? Okay. Last, maybe the second last one. It says create a back-to-back StemPlot for this data. Okay, so again, we got another StemPlot. Back-to-back, and the reason why we have a back-to-back is because we have 2 different pieces of data here. Okay, this is the amount of M&Ms that these teachers have eaten during any one day. Okay, and these are random days. And so here's what I need to do. I'm going to do the same thing as before. I'm going to make, let me see if I can find my guy here. Oh, that's not too bad. Hold on. Forgive me. If I were at my whiteboard at school, this would be so much easier to fix. Okay, so let me try again. That was kind of long. Okay, like, does it need to be this long? It doesn't, but it's okay. Stem, leaf. Okay, and what I'm going to do is, while I'm going to work with Miss Chesley to start with, I want to consider all the data. Okay, so between all the data, the lowest number I think I see is in the 30s. Okay, so I'm going to start in the 30s here. And the highest I see is 121. So that would mean that for tens purposes, yeah, that's 12. 12 sets of 10 is in the 120. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. All right, and then I'm going to work with Miss Chesley here. Now, if I look at just the numbers in the 30s, okay, there's 32. If I look at the numbers in the 40s, here's a 40, here's a 40, there's one, there's one, there's one, and there is one. So let me pick the lowest of all those X's. It's 42. I'm trying to avoid a rough draft. 43 is the next one. 44, 45, and 48. 1, 2, 3, 4, 5, 6. 42, 43, 44, 45, 48. Did I forget 46? I did. There we go. All right, in the 50s, I have 52. I also have a 50, and I have a 53. So I'll just kind of mark those with little zeros. 50, 52, 53. And then I've got a 62 and a 70. All right. She has done. I'm going to write Chesley on the side, so I label it correctly. Okay. And then I'm going to do Mr. Castillo's. Okay, now to do Castillo's, what I'm going to do, oh, what did I do? Is make another line going vertically. And back to back means I have to go out this way now. Okay, and I'm going to make a leaf towards the left and call this side Castillo. Okay. And so if I look at Castillo, and maybe I'll do this in a different color just to mix it up a little bit here. I'll do this one in green. Let's see, the lowest that I see from his group is 74. So I will write that over here. This guy is gone. He has a couple in the 80s. He has 83 and 88. So I'll write this here. Now, as you write these, the smaller number always goes closest to the stem. Okay, so when I consider 83 and 88, the 3 will go first, and the 8 will move towards the outside. Okay, so there's your 83, there's your 88. The next one is 92. Okay, and then I've got 95 and 97, so those will go outward as they get bigger. And then I got 101. I have 102. And then I've got 121. All right, now that looks pretty good. I am going to write a key, just like I did on the very first one that I did. I don't think I did it on the last one, but 32 is equal to 3 space line 2. Okay. All right, now comparing the distributions. Big part of your answer. In fact, that's bigger than the math piece that you see here, okay? But what they want you to do is they want you to compare using socks the using those 4 items, the differences between Miss Chesley and Mr. Castillo. All right, so shape. So let's look at Miss Chesley because she was first. Her shape looks a little bit skewed, okay? It seems to tail off towards higher values. So that's what I would say in context to start with. Okay? Miss Chesley's M&M distribution, okay, per day, okay, is slightly skewed. And I say slightly because there's really not a whole lot of data. Toward, now again, I'm going to ask myself, where's the tail? The tail is over here. Okay, so towards, I'm going to say higher values. Okay, as you read this data, you're moving from lower numbers to higher numbers as you move down. Okay, that gets confusing because people think higher is the one that position-wise is more on top. Okay, and that's not correct. It's the number value that's more important. Okay, so higher values are moving downwards. Okay, so towards higher values. That's a big H. Okay, and if you look at Castillo's, whereas, let me fix that. Castillo's looks, I would say to me, approximately normal. Okay. Is that green? All right, whereas, where's my little guy? Goodness. All right, whereas Castillo's, yeah, if you look at his, it's tough to do. There is a gap here, okay, I get that, but it does look a little bit more normal than what I see over here, okay. I'm gonna go with that. Like, dang, that's a lot of writing for statistics. It is. Okay. All right. Oh, does there seem to be any outliers? Well, if I look at Miss Chesley, I don't think there probably is. There's not a data point that seems to veer off more strongly than the other ones. Okay. If I look at Castillo's, some may think that this one is, but the fact that it's a 1, it's really a low value for this 120, and I'm only skipping one interval, even though these are smaller too. I don't know if there's any outliers. Okay, maybe, maybe not. I'm just going to say no. I don't believe there is based off what I'm seeing. Okay. Okay. So I would say there does not appear to be any outliers. Cool. C, center. All right, let me count because Miss Chesley here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wonderful. Goodness. All right, so what that means is there must be a center or a median that is going to involve a little bit of math. I have to go 6 in each direction. Okay, so 1, 2, 3, 4, 5, 6. There's that guy. And if I go 6 the other way, 1, 2, 3, 4, 5, 6. It's between the 26 and the 28. So for Chesley, between 26 and 28, I don't have to show the work for this. Chesley has a center at 27. And Castillo, let's see, how many has he got? 1, 2, 3, 4, 5, 6, 7, 8, 9. Woohoo! Which means I have 1, 2, 3, 4, 5. 5 in each direction means that 95 is the center here. So Castillo's is actually much higher. At 95. Cool. It keeps doing that, sorry. All right, finally is the spread. Who has a larger spread? Well, if I look at Chesley's, her low value, remember I don't subtract this, Chesley's spread is, and we'll just say from 32 to 70. Okay, Castillo's is 47 to 121, and I think his is a little bit larger. Okay, and so I'll say that Castillo's spread is larger. Okay, and I'm going to write it out. It's from 47 to 121. All right, and there you go. Okay, so notice that there is a compare. Okay, I'm going to go back way up here. Where am I at? Okay, and notice that just the directions. That's what it shares. It is asking you to compare the two. And is that a lot of writing? It is, no doubt. But that's part of expressing your complete understanding for what's going on in this problem. You're analyzing all these little different parts between the spread and the center, and are there some numbers that are outliers that may distort your data a little bit? And looking at the shapes that gives a full representation of what a distribution is. Okay. All right, last thing is not hard at all. It asks you to find the, sorry, pen mark. Take the numbers and to create a histogram. Okay, now you're like, what is a histogram? A histogram is kind of like a bar graph, but one, your bottom numbers, so your horizontal axis is represented by numerical values, okay? And your bars are not separated. They're actually right next to each other. So let's look at Chesley's numbers here. It looks like, again, the lowest number is 32, the highest is 70. We can ask ourselves, what would we like to count by in terms of our intervals? And I would say maybe tens is a good one, okay? Tens will give us enough bars to give us some type of shape, okay? So let's look at this. Let me find my guy here. Let's do a different color here. We'll do blues. And you can do this a couple ways. You could say 30 if you want, and then count this as 40, and count this as 50, 60, 70, 80. Since we have nothing below 30, it doesn't hurt to just put a little zigzag there to say that there was some break, because we know that from this location to 30 is not the same distance as 30 to 40 and so on. Okay. Now, what this means when I draw my histogram is I'm going to count by a frequency of how many I would have in each group of 10. All right, so if I look at, for example, 32, that's in the 30s, and I think that's it. Okay, I'm just going to say there's one of them, so I'm going to count up one spot, and this is my frequency. How many do I have in the 40s? Well, there's 1, there's 2, there's 3, there's 4, there's 5. So I'm going to count up 5. Go down. How many in the 50s? Well, there's 50. Ooh, did I forget another one? Darn it. 1, 2, 3, 4, 5, 6. Let me erase that. That worked out good. Cool. All right, 50s. I've got 1, I've got 2, I've got 3. All right, and let's see, 1 in the 60s, 1 in the 70s. Okay, and so if I count this, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, just like before. And this is 1 plus 6 is 7, 8, 9, 10, 11, 12. All right, let's label this well. This is the number of M&Ms. Okay, and I want to address something. And to keep notice of, is a number like 50, okay? And if you look at 50, 50 is right on this border, and you're like, hey, where did that go, okay? If your number is ever a number that's on the border between one part of your histogram and the other, that number will always go to the, I'll say kind of like, it looks like the bar on the right-hand side, okay? It always goes to the one on the right, okay? So your number 50 was actually in this group, okay? Similarly, the number 70, you're like, wow, 70 is on the border. Should I count 70 over here or 70 to the right? And it's always the one on the right, okay? So 70 was actually in here as well. Some people are like, can I just write it like this? Can I say, hey, from 30 to 39, like make this spot 30 to 39 and make this 40 to 49? Since M&Ms are discrete numbers, okay, and you can't really have a half an M&M or a third of an M&M unless you bit into it, then yeah, you could have written them like that. That's certainly okay. Just say, hey, this is 30 to 39 or 40 to 49 because you want to make it just a little bit more clear to you. That's certainly fine. Okay? All right. I think you already knew that was the last one because I keep blowing through my slides on accidents. And that is it. The big piece for this assignment is making sure that you are complete with your socks, okay? You cannot shortcut that. Not on your homework, not on your tests, not on your AP tests, because they will nail you hard if you don't include all of these when they say describe the distribution. Okay, that is so important that you include it all in, and in some case, somewhere, context. All right, if you can do these 4 things, and I don't even think they're big math things, they're more of details, okay, that helps make your work sound complete, you'll nail your test perfectly every single time, okay? Sometimes people just do 1 or 2 of these to help answer a question, and it's like, oh, I'll do the outliers, and I'll do the center, and they end up getting a big part of it wrong, okay? And not because these parts were incorrect in what they wrote, but it's just not complete. You have to have everything. Okay. If you have any questions, holler at me, send me an email, let me know you want to see on Meets, Google Meets, and I'll help you on it. Okay. Good luck on this. If this is a Friday assignment for you, it'll be due on Tuesday. And if it is a Monday assignment for you, then it'll be due on Wednesday. Okay. All right. I hope you have a great day. I'll talk to you soon.